Hey y'all, welcome back to the unit on finding area of polygons, and today we're going to talk about the area of trapezoids, rhombuses, and kites. This will probably be 2 videos. This will be the first of however many, depending on how long I talk. So we're going to buckle up and learn some stuff about finding the area of trapezoids. That's how we're going to start. So let's begin with a note about the area of a trapezoid. Now, if what you can remember from a trapezoid is that it's a quadrilateral with one pair of parallel sides. So the parallel sides end up being the bases. So we got to know when we're talking about a trapezoid, the bases come from the fact that those are the parallel sides in the trapezoid. So it doesn't matter how big or how small they are, if they're parallel, those are the bases in the trapezoid. So we have a measurement of course, distance, which is the measurement of one of the bases, measurement of distance, again, another base, and a measurement of the height. We can have a formula for finding the area of a trapezoid. Now, the way the book calls it is 1/2 height times base 1 plus base 2. But I call it something else. So the way I define the area of a trapezoid is saying the average of the bases times the height. Okay, so when I'm talking about area of the trapezoid, it's the average base. And how do you find the average of 2 things? Add them and divide by 2. See how that works? Yep, I hope you paid attention. Pay attention! Add them and divide by 2. So that gives you the average base and multiply that times the height. Now, you can also view trapezoids as rectangles and right triangles. And that's helpful as well because it can start getting into some interesting stuff when we start talking about measurements. So we have our trapezoid, which can be split up into rectangles and right triangles. Now, whoop-de-doo, Mr. Katz. Well, whoop-de-doo indeed. Because when we start talking about right triangles, we have to remember a few important things. The first of which, well, with our right triangles, we have to remember Pythagoras. Pythagoras comes back to play. Okay, so you got to remember Pythagoras with the Pythagorean theorem. The square, or the sum of the square of the legs is equal to the square of the hypotenuse, right? So Pythagoras comes back to play when we talk about right triangles. And our little shortcuts for the Pythagorean triples, 3, 4, 5, because I'm going to use that. Okay, I'm going to use the 3, 4, 5 Pythagorean triple later. So this will come in handy. So we have to remember that about right triangles. We also have to remember about right triangles our special right triangles, the 30, 60, 90 right triangle, where we have a short leg, we have a long leg, and we have a hypotenuse. And if we remember, the short leg is half of the hypotenuse. The long leg is the short leg times the square root of 3. So we have to remember that with our 30, 60, 90 triangles. And we also have to remember the 45, 45, 90 right triangles, where we have our 2 congruent legs and the hypotenuse being the leg times the square root of 2. So when we talk about viewing trapezoids as rectangles and right triangles, we got to remember that. And also, I ain't done. We got to remember trigonometry. Okay, so we got to remember sometimes we talk about angles and our trig ratios from perspective of angles. The sine of an angle being the opposite leg over the hypotenuse, the cosine being the adjacent leg over the hypotenuse, and the tangent being the opposite leg over the adjacent leg. So all these things have to be remembered when we talk about trapezoids. Okay. Finally, can we get to work, Mr. Katz? I know. Let's go. Yap, yap, yap. That's all I do. Talk, talk, talk. Okay, let's get to work. So we talk about the area of a trapezoid. I'll begin with a word problem. Yay. So we're going to find the the approximate area of Nevada. So we have this little trapezoidal figure of Nevada. Now tell me, wait, Mr. Katz, trapezoid? What you talking about? This is a trapezoid, Mr. Katz. That ain't a trapezoid. And I say, whoa, time out. Remember what I said. If you have one pair of parallel sides, you have a trapezoid on your hands, right? So when we look at this diagram, we have to first identify what are our parallel sides. And hopefully you can see that the western border and the eastern border are parallel. Okay, so with that, guess what we have? Indeed, we do have a trapezoid. Okay, so remember I said no matter how crazy, big or small, whatever, if the sides are parallel, we got a trapezoid in our hands, folks, and those are the bases. So this means we have a base here of 205 miles, a base here of 511 miles. Well, then what then would be the height of the trapezoid? So hopefully you see the height then is 309 miles. Okay, so now what you can do, if you want to follow the textbook example, plug and chug, man. A equals 1/2 HB1 plus B2, right? You can just plug and chug. But remember me, I like to use a little bit more conceptually appropriate things like the average of the bases times the height. Okay, so I'm gonna use that. It's the average base times the height. So how is it that we're gonna find the average base? So we add our two bases and divide by 2. That's our average base. So it's 205 plus 511. And if we divide that by 2, we have our average base. Okay, so the average base would be whatever number that turns out to be. So let's bust out our handy-dandy calculator, do a little bit of 205 plus 511, the equal sign, then divide by 2, and the equal sign. So it's 358 miles. So the average base is 358 miles. And we multiply that times the height. And so when we multiply that times the height, we're just going to multiply 358 times 309. And that will give us our area. So our 358 times 309, that gives us our area. So it's a pretty big number. It's 110,622, right? Big old number. So that would be our area of Nevada. Okay, that's a pretty big number, 110,000 square miles-ish. So remember, it's the average base times the height. Okay, so remember how I was talking about the area of a trapezoid. The average base, that's a G, by the way. Come on, cats. The average base times the height. And that's the area of our trapezoid. So it turns out in this case it would be 110,622 miles. Let's just say, right? So there we go. That's how that works. Ready? Let's do it. Another example. What is the area of a trapezoid with a height 7 centimeters? Whoa, cats! Easy. Holy cow. Square miles. What's wrong with me? Miles squared. That was close. See? Units of measure are very important. Miles are distances. Square miles are areas. And we're talking about areas. So, oh, shame on me. Anyway, hopefully you didn't get too lost. So let's continue. Power on. What is the area of a trapezoid with heights 7 centimeters and bases 12 and 15 centimeters? So remember what we're going to look for. We want the area of the trapezoid to be equal to the average base times the height. Okay, so I'm going to find the average base between 12 and 15. So the average base in this case is going to be 13.5, but we'll find out the hard way. So we're going to do 12 plus 15 equals, we divide by 2. Okay, so it's 13.5, like I said. So we're going to add 12 plus 15 and divide by 2. 13.5 centimeters is our average base. So again, average base, 13.5 centimeters. And the height was given as 7 centimeters. So all we do is multiply those. So times 7, equal button, 94.5 square centimeters. Okay, so that's as simple as that. Pretty straightforward, right? 94.5 square centimeters, because we're looking at an area, right? So distance in 1 dimension, area in 2 dimensions. Okay, let's make this hard, and then we will call it a day. Oh wait, no, not yet. One more basic question. So suppose the area of a trapezoid is 126 yards squared. If the bases of the trapezoid are 17 yards and 11 yards, what's the height? Well, we got to remember, how did we get to the area? The area of the trapezoid is equal to the average base times the height. So we have to first find the average base. The average base is between 17 and 11. So how do we do that? We always do 17 plus 11 and then divide that by 2. and we end up with 14. So the average base is 14. Let's see, what's the height? Blah, 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 blah. The height is what we're looking for. It says, what is the height? So that becomes our variable. And then we have our equals on, equals what? Well, it equals the area, right? So let's read. Suppose the area of the trapezoid is 126 square yards. Got it. So 126 square yards. How is it then that we're going to find the height? Of course, a little bit of basic algebra. Divide by the old 14. And so was that 1, 2, 6 divided by 14, and it would equal 9. Oh, that's convenient. So 9 equals h. Now, I'm not circling this because units of measure are important. Is it 9 yards squared or is it 9 yards? Okay, so this is the question. Is it 9 yards squared or 9 yards? So we got to think. What are we looking for? We're looking for a height, right? A height is one dimension. Area is 2 dimensions, yards squared. Height is 1 dimension, just yards. So it certainly isn't yards squared. It is 9 yards. We have to know the difference in dimensions. It's pretty darn important. All right. Now let's make it challenging, and then we will go home. Well, I'm not going anywhere. I have more work to do. You can go home. Wait, you probably are home. Let's continue. So now what we're going to do is find the area with right triangles. Now remember in the notes, when we talk about right triangles, we've got a bunch of things going on. We have our special right triangles, 30, 60, 90, 45, 45, 90. We have Pythagorean theorem, 3, 4, 5. We've got trigonometry, SOHCAHTOA. So a lot of things that go on with right triangles. So now, with that being said, find the area of this trapezoid, PQRS. Well, it's the average basis times the height, right? So area of the trapezoid is equal to the average base times the height. Okay, but the problem is we don't know the height, right? We need a height, right? So clearly we know the average base. Between 5 and 7 is going to be 6, right? 5 plus 7 is 12. 12 divided by 2 is 6. So we know that the average base is 6 meters. If that went too quick, make sure you listen to the words I'm saying. The question is, how is it that we find the height? Well, what is the height? The height is from the top perpendicular to the bottom, thus creating a right triangle. Okay, so you got to remember, right triangles, okay, and that brings in special right triangles. Now, if what we don't know, we have now a 30, 60, 90 right triangle. Okay, so we have the 30, 60, 90 right triangle. And all of the beauty that comes with it. Now the 30, 60, 90 right triangle follows this pattern. The short leg is half the hypotenuse, so the hypotenuse is twice the short leg. And the long leg is the short leg times the square root of 3. We have to remember that, and so we're about ready to use it. The only challenge is we don't know the short leg. Or do we? Right? What we need to know is the height. What we need is the long leg. In order to find the long leg, we need the short leg. So how are we going to find it? Well, the old segment addition postulate, but backward. So if it's 7 meters all the way across and 5 meters from our rectangle, that will leave us 2 meters as the short leg, which means our height then is 2 times the square root of 3. That's how many meters the height is. 2 times the square root of 3. Okay, so that gives us the height. So of course the area then is the average base times the height. So in this case, the area would be 6 times 2 times the square root of 3. Okay, so 6 times 2 times the square root of 3 is 6 times 2, which is 12, times the square root of 3. So it's 12 times the square root of 3. So let's talk about square meters, first of all. If I was asking about simplified radical form, that would be simplified radical form. We'll call that radical. It's radical. Or it could be decimals, right? So how would we do that with decimals? 12 times 3 square root equals, it could be 20.8. Okay, so it could also be 20.8 meters squared if we were talking about rounding. Okay, so we have a few things that we can talk about depending on what we're doing. Okay, one last example with trigonometry, and we'll call it a day. So here's another example of a triangle, a trapezoid. What did I say? And we're going to find the area. So once again, area is the average base times the height. Average base times the height. But in this case, we don't know the average base. Or excuse me, we do. We don't know the height again. Okay, so here we go again. Here's our height again. So we're going to look for that height. Well, again, the average base should be pretty straightforward. 5 meters, 7 meters, add them, divide by 2. The average base is 6 meters. So what in the world is the height? Well, we're going to do some segment addition postulate, but backward. All the way across, the bottom base is 7 meters. All the way across, the top base is 5 meters. That leaves, for this leg here, again, 2 meters. Now, how do we find that height? Folks, I hope you see this, but we are looking at a 45, 45, 90 right triangle where the legs are congruent. The hypotenuse is the square root of 2 times the leg, right? So if the legs are congruent, and this leg is 2, guess what? This leg is also 2. So that makes the height 2 meters. So the area then would be 6 times 2, which of course is 12 meters squared. That is neither simplified radical form nor rounded because we don't need any of that. It's an integer. Huzzah! So that's it for this video. We'll come back with a second video about rhombuses and kites. Hopefully you learned some things about trapezoids. Peace!